Hello class, this is just another example on the period of a trigonometric function and how to graph them. So let's get straight to it. Let's do this first one, cosine 3x. Now, how difficult you make this, I'll just let you know right now. It's not normally that we're asked to graph multiples of 3, but when you do, it's best that you divide your partitions into thirds rather than quarters or halves, as I've shown here. So your increments should be 1/3, 2/3, and then 1/2. So in this one, it's quarter, half, 3/4, whole. So it's good that if you're going to see that it has 3x, your increments should be in thirds. You'll see why in a moment. So let's get straight to it. First, let's find the period of this function. Now remember, it's always going to be 2 pi divided by whatever that value is. So 2 pi divided by 3, well, that's 2 pi on 3. Meaning it's going to finish one cycle. So this cycle here is going to fit in one cycle here. So it's going to be a very tight graph. Now, let's graph each of the critical points. Let's let this one be 1, and this point here be -1. This one here cannot move left or right because its distance from the y-axis is already itself. Let's look at this point now here. So originally, it's pi on 2. And much like here, how we divided by this coefficient, we're going to divide by 3, which will become pi on 6. Pi on 6 is actually halfway between 0 and pi on 3. So it should already look something like this. That's this point done. Let's look at this point here. This point is at pi on, just pi, sorry. So its lowest point is at pi. Because of this dilation, we're going to divide by 3. So pi divided by 3, well, that's just pi on 3. So this lowest point is now going to be at pi on 3. There we go. This point here is 3 pi on 2, and we're going to divide that by 3. Now we can write this just as a fraction. This is going to be divided by 3, that's right. But that's 3 on 1, which is the same as times 1 on 3. The 3's cancel, leaving us with pi on 2. Pi on 2 is exactly halfway between 0 and pi, which looks to be about here. There we go. And as we said, that this cycle ends on 2 pi on 3, so it must come back up here. Now, as you can see that this is already one cycle, we can just repeat this pattern for all the rest of the critical points. So 1/2 step comes back to 0, like so. Another half step goes to its lowest point. So one more half step goes to its lowest point. Another half step goes back to its 0. And this cycle continues like so. There we go. And let's just circle all the critical points that we should find. Now, if ever you're asked to find what value this point is, you can consider it being the halfway point between 4 pi on 3 and 5 pi on 3. You can do that by finding the halfway point. So 4 pi on 3 plus 5 pi on 3. We're going to halve that and divide everything by 2. It's finding the mean or the halfway point between those two. So that is the graph cosine 3x. Alright, so it's very difficult graphing multiples of 3 of this coefficient. And if ever you decide to do that, be sure that you have increments that you draw to be thirds instead of multiples of 2. But originally, we are often asked to graph in multiples of 2, so sine 2x, cosine 4x, etc. I would like to delete this. Alright, so let's get straight to our next example. Here we go. Cosine 2x, thank goodness, it's back to multiples of 2. So once again, let's find the period first. So the period is going to be 2 pi. It's always going to be 2 pi. And we're going to divide by that value there. The 2's cancel, leaving us to pi, meaning one cycle will finish between 0 and pi. So let's let this one be 1 here, and that point here be -1. So now let's find all the critical points. Let's move this across. So we're always beginning on 1 because it's matching that point, so we're finished with that one. This point here at 0, it's originally at pi on 2, but we're going to divide this by 2. So this will become pi on 4. So what was originally 0 at pi on 2, so it was originally here, will now be moved to pi on 4, like so. This lowest point here is pi, and we're going to divide this by 2 as well, which gives us pi on 2. So its lowest point is originally at pi, so it's originally here, but it will now be here because of this change. This point here, so we're finished here. So that point there, this latest one here, is now going to be divided by 2 as well. So 3 pi on 2 divided by 2 becomes 3 pi on 4. So it's originally 0 at 3 pi on 2. It will now be 0 at 3 pi on 4, like this. And as you can see, the cycle will finish back to pi. And this cycle will repeat itself. So one step across goes back down to 0. One step across again goes to the lowest point. So one more step across goes to its lowest point. One more step goes back to 0. And one more step goes back to the end of the cycle. There we go. And that's how we graph cosine of 2x. One more example. Let's, again, multiples of 3. It's very difficult. If ever you are asked to do it, make sure that your increments are in thirds or sixes instead of halves or quarters. So let's first find the period of this. Period of this is always going to be 2 pi divided by 1/3. We can simplify this as 2 pi divided by 1/3, which is the same as 2 pi times 3/1, which is just 2 times 3, which becomes 6 pi. So this is actually going to be very stretched out. In actual fact, I'm actually only going to stop at 4 pi. I'm not going to complete the cycle. Let's move this down to find our critical points. Here we go. Let's erase this. So, beginning at 1, this point here cannot be stretched because it's already on the y-axis. this point here is originally pi on 2, but we're going to divide by 1/3, which is the same as times 3 on 1. So that will become 3 pi on 2. Okay, so this point here is pi on 2 becomes, so pi on 2 is here. 3 pi on 2, oh my, that's going to be difficult to find here. 3 pi on 2, that's 1.5. 3 pi, yeah, 1.5. So it's going to be 1.5. So pi is 1, and half looks to be about there. So that point is, it's 0. Let's move to the next point. It's originally at pi, and we're going to divide by 1/3, which is the same, dividing by 1/3 is the same as multiplying by 3. That becomes 3 pi. So its lowest point, which is originally at pi, is now going to be at 3 pi. So its lowest point is going to be here. Okay. One last point here. It's going to be at 3 pi on 2. We're going to multiply by 3, and that will become 9 pi on 2, which is 4.5 pi. In actual fact, that goes on the end of the graph, and we actually can't reach that. In actual fact, because the graph is asked to be drawn only from 0 to 2 pi, we could have stopped graphing at this point here. But in any case, I hope that gave you a deeper insight into graphing different changes of the period of trigonometric functions. I'll see you in the next video when I do one more example with tan.